Hi class, welcome to your first distance learning video lesson. Before today's lesson, you must download and install the free calculator student software from TI. The link is in the description and you should choose the TI Nspire CX. This calculator software will allow you to have a picture of the school's calculator on your computer that's functional, where you can press all the buttons and have a calculator right on your computer. At this time, you should pause the video and you should download the calculator software. So by now you should have paused the video, downloaded the calculator software, and have a calculator on your computer and ready to go. Today's topic is a review. We are going to be talking about reference triangles and right triangle trig. You need to know the trig ratios, which we can abbreviate SOHCAHTOA, the sine, cosine, and tangent ratios, and the Pythagorean theorem. I sent out notes on the trig ratio formulas. It looks like this. You should have those in front of you. Before we can jump into the lesson, we need to go over one piece of vocabulary, and that is a reference angle. A reference angle is what it sounds like, an angle. A reference angle is an angle. Specifically, it is an angle inside a reference triangle that is closest to the origin. So a reference angle is an angle contained in a reference triangle that is closest to the origin. We use the symbol for a reference angle, theta prime, or theta reference. So we read this as theta reference. We read this as theta reference, and your reference angle has to be between 0 degrees and 90 degrees, meaning a reference angle is an acute angle. All right, let's jump into our examples. All right, so we have a diagram here that is going to be used for examples 1, 2, and 3. We have been given that OP is 6. So here's O, the origin, here's P, the length from O to P. The length of this line is 6 and it is labeled. And example 1, we are going to draw and label, this is our new symbol, theta reference. So remember, this is read as theta reference. Okay, so I see that angle theta is in standard position. Angle theta starts from the initial side and goes all the way to OP. Angle theta is going to be an angle, see how it's more than half the circle? It's going to be larger than 180 degrees, but I know theta reference has to be between 0 and 90. So I am going to draw my reference triangle. Recall that to draw a reference triangle, you put your pen on point P and draw a straight vertical line to the x-axis, forming a right triangle. Now I have a right triangle, and theta reference is the angle in that triangle closest to the origin. So here's the triangle, here's the origin. The angle that I'm talking about is this one right here. This angle is theta reference. Theta reference. That brings us to example 2. I need to find theta and theta reference. So the way I'm going to do that is with my trig ratios. I know to use my trig ratios because I am dealing with an angle. If I'm only looking at sides and I don't need to use an angle at all, then I could use the Pythagorean theorem. This is asking for an angle. I am going to need to use the trig ratios. So I've got my triangle here. I'm going to label any sides that I know. I'm given that the point P is x, -5. What that means is to get from the origin to P, I have to go a distance of x to the left, and then I have to go a distance of 5 down. So this length here is -5. So what I've got is a triangle whose hypotenuse is 6 and whose one of the legs is -5, the other leg is unknown. Since I'm using trig ratios, I'm going to go ahead and label the sides opposite, adjacent, and hypotenuse. The hypotenuse is 6. Here's my theta reference that I'm dealing with. The opposite is the side that I drew, so -5 is the opposite, and that makes x the adjacent. A hint for y'all, the opposite is always y, and the adjacent is always x. You might want to think about how that relates to your unit circle. At any rate, I'm trying to find theta reference and then theta. We will need a calculator here. I'm going to set up a trig ratio that includes the sides that I know as well as theta reference, because theta reference is in my triangle. The sides that I know are the opposite and the hypotenuse. So looking at my trig ratios, opposite and hypotenuse. Okay, opposite, hypotenuse, it looks like sine is going to be a good function to use. I could also use cosecant, but I'm more familiar with sine. I'm going to use sine. So I'm going to set this up as sine of theta equals opposite over hypotenuse. Okay, I'm going to start with finding theta reference. This is important. When you find theta reference, you are going to only use positive side lengths. We are just going to ignore negatives. So I'm going to be finding theta reference, because that's the angle in the triangle, by using the opposite and hypotenuse. However, my opposite is -5. I'm just going to consider that 5. So I'm going to set this up as the sine of theta reference equals the opposite, which is -5, but I'm going to be using 5, over the hypotenuse, which is 6. Now I'm trying to find theta reference, so that means that I have to undo the sine function. In order to undo the sine function, we are going to use sine inverse. I'm going to take sine inverse. Whatever I do to one side, though, I have to do to the other. So sine inverse. Sine inverse and sine cancel out. Notice how theta reference is by itself now. Theta reference equals the sine inverse of 5/6. Okay, so we're going to go to our calculator now. And we are going to, my calculator battery is low. You guys should pull up your calculator on your computer. If I go to the calculate screen, now I'm using a trig function. Notice that I'm in radian mode. I'm probably going to want degrees here. So if you recall how to do that, we hit dock 7.2. The angle changes to degrees, and then we make default. I'm going to enter in my calculator what I have written down, which is sine inverse of 5/6. So sine inverse 5/6. You can use a fraction button if you want. And I get 56.4427 degrees. That is my theta reference. So theta reference equals 56.443, I'm going to round, degrees, which is a reasonable answer because it's between 0 and 90. That's theta reference, but the question also asked me to find theta. So I'm going to have to look at my diagram here. Theta goes all the way from the initial side all the way to the hypotenuse here. And theta reference is just this little part. So this guy would be theta reference. hopefully y'all can see the connection between theta and theta reference. In this third quadrant, theta reference is theta is going to equal theta reference plus this extra half a circle. Well, half a circle is 180 degrees, so in this case, theta is going to equal 180 degrees plus theta reference. And this is for quadrant 3 specifically. You have to kind of figure it out for the other quadrants. So I'm going to add 180 degrees to my previous answer, and theta is going to equal 236.443 degrees. All right, one more example with this picture. Example 3, I am going to find x. Example 3, I'm going to find x. So I'm going to redraw the diagram that I have. This length is 6. This length right here is -5. Right triangle, here's x. And I'm going to use theta reference. Theta reference, recall, is 56.443 degrees. I can either use a trig ratio or the Pythagorean theorem. We have already done the the trig ratio, so I'm going to do this with Pythagorean theorem, but both would work. Now, when I use Pythagorean theorem, I again am going to ignore negatives. Because when I square things, the negative squared and a positive squared are going to come out the same. So I know that x squared plus 5 squared equals 6 squared. Doing some subtraction, x squared is going to equal 6 squared minus 5 squared. And I can do the math here. So x squared is 36 minus 25, and 36 minus 25 is 11. So x squared is 11. X is the square root of 11. Oh, but we have to check the reasonableness of our solution. Now remember, x is a coordinate plane value. Here's the origin. Notice that I'm going left. So that means because I'm on the left-hand side, that x has to be a negative number. Your math is not going to come out negative, but your answer is. X equals negative the square root of 11 because I was going to the left. That means that point P has the coordinates negative root 11, negative 5. One more example. All right, it's a word problem this time. Example 4. Let O be the origin and P be a point on the terminal side of theta and angle in standard position. Oh, great. That's very similar to what we just had. I need to find OP when the x coordinate is 12 and the theta is 50 degrees, correct to 3 decimal places. So I'm going to draw this situation. All right, here's O, the origin. Theta is 50 degrees. Well, in standard position, here's 0 degrees. Here's 90 degrees. 50 is between them. So P is going to be in quadrant 1. So I'm going to say that maybe about that is a 50-degree angle. And here is P. And I'm going to label this 50 degrees. That's my theta. They gave me that the x coordinate is 12. So if I draw a reference triangle here, to get to point P, I have to go 12 units to the right and y units up. They have asked me to find OP. OP is the length from O to P, And so that is the hypotenuse here. And that is my question mark. All right, well, I only have one side, so the Pythagorean theorem is inappropriate here. That means I'm using a trig ratio, and I am going to label my sides. OP is the hypotenuse. Here's theta. So next door to theta is x, and remember x is always adjacent. And the third side that I drew, the vertical side y, that is going to be my opposite. Well, I don't know y, so that's not going to be very good, and I'm not trying to find it. I'm trying to find OP, and I know 12, so that's adjacent and hypotenuse. Adjacent and hypotenuse. Well, adjacent and hypotenuse, oh, my camera's a little fuzzy here, sorry about that. Adjacent and hypotenuse, that's the cosine. So I'm going to use the cosine function to solve this problem, and I'm going to write out my formula. Cosine of theta equals adjacent over hypotenuse. Now I'm going to fill in what is known. So cosine of, I do know theta, it's 50 degrees. Cosine of 50 degrees equals adjacent, I do know adjacent, that is 12, over hypotenuse, I don't know that, we're going to keep calling that OP. Okay, now I have to solve for OP. So here's OP, what I'm solving for. I am going to start by multiplying both sides by the denominator. Even if I were solving for the numerator here, you would always just multiply both sides by whatever is in the denominator. In that case, it's OP. So times OP, times OP, and let's use this as a segment. I'm going to call OP a segment so that we can see what we're talking about. OP cancels out, so I'm left with segment OP times the cosine of 50 degrees equals 12. Now remember, we're solving for OP, and that's not by itself yet. So I can do some division to get OP by itself. I'm going to divide by cosine of 50 degrees. Whatever I do to one side, do to the other. Cosine of 50 degrees cancels out. We get that the length of OP is equal to 12 divided by the cosine of 50 degrees. We can type that in our calculator, which again you should have on your computer by this point. I'm going to use a fraction button here. So I've got 12 over the cosine of 50, and I am in degree mode, so that is fine. And we get 18.6687. 18.6687. That is the length of OP. That's this length here. And it is longer than 12, so that is a reasonable solution. All right, y'all have an assignment posted on Google Classroom. You have class on Wednesday. Thank you guys for watching, and have a great day.